Welcome to Math, Minecraft Computers, episode I33, where we are building our register in Minecraft. We designed it last time in Logisim. It's time to build it in Minecraft. We'll be using 8 D-type flip-flops, and we'll get to it. What I have done is I have built an 8-bit bus here that does not have the inverted lines, and you can see that we have just 1, 2, 3, 4, 5, 6, 7, 8 of these lines. They have a switch, as you can see here, that will also turn on a light here at the front so we can see which ones are on or off on the bus. I've labeled them B0 for bit 0 to over here, of course, is going to be bit 7, and that's our 8-bit bus. Now the other thing that I have here is I have the enable line coming here, and you can see that what I've done already is I've copied one D-type flip-flop here. And the reason I did that is those others that we built on the other side face south in this direction, but I want these to face west in this direction. So I've already built that here, and you can see that the enable line is running on top of a yellow block, so we know that that's a control line for enable. Other than that, it's the same. Over here is our queue where we'll actually store the bit. It is currently storing a bit. And then what we want to do is, of course, we want to make 7 copies of this in that direction in the exact same place. So I think it's a good time as an assignment for you to see if you can figure this out on your own, how you could actually copy this. So let me put up a screen for about 5 seconds or so while you figure that out, see if you can do it, and then we'll go over it. Okay, to copy this, remember that we want 8 copies of that. We want them lined up here. So do a little math to figure this out. What we want to do is we want to start with our block. We want to face south. That means put the sun over there to our left, facing south. As you remember, Minecraft copies in a positive direction for all of the axes. In this case, positive moves us here. You can see that we're at 220, 221, so it's going to copy in that direction for that axis. That is the X. The Y axis, which is actually listed to the 3rd in Minecraft, which is right here. You see moving forward to the south increases it. And then, of course, as you look up, you can see that you end up with higher values. So it's going to copy from, in this case, right to left, front to back, and bottom to top. So we just need to find our extents. Well, we know we need to get this block here. You can see that our last chunk is this block here. And we also need to go 2 down. And we want it to line up with our light right there, our Minecraft lamp. So we look at 2 down and replace that with blue. So there's our first copy block. That will get the redstone that is underneath here, right there. That's 2 down. If we want to get the yellow 2, we need to go 3. So that's deciding what we want to do. I do want the yellow because it's a signal. So we're going to go over here and go down 1 more. Like this, and we put our blue block down there. So we're going to copy down 3. You can see then that our Z component here in the middle is 12. There's 13, 14, 15, 16, and then don't forget we have a block sitting on top, 17. What we want to do is we want to know our dimensions. Now we're going to copy in this direction. We're going to go over to here, and we want to stop copying here. We're going to handle the actual control line for the enable differently there. So we're going to put that on top. And you can easily see what's the highest by doing that. That's the highest we have is that redstone. And you can see that this block lines up with that redstone. It doesn't look like a block, but there is a block sitting there. So there's where we want to copy to. Now we just need to write down our starting dimensions for this. If we come over to this one, we can write them down over here on the right. You can see in the targeted block that we start at 220, 12, 125. And our ending block is going to be this one here that we have here. It's right above our inverter where we start, which is fine. And that is 241, 17, and 133. Find a difference. Obviously, we use subtraction. You want to find a difference in something, we will do subtraction. So we'll start with the coordinates of this block over here that we talked about. And that block is at 220, 12, 125. That's where we're going to start. That's the source of our copy. Now we know then that we're going to 241, so we would subtract these very simply, and that is of course 241 minus 220, which gives us a difference of 21. Now, there's something you have to do when you do any sort of difference that way. If you start measuring something, here will pop up a quick ruler graphic. If you start measuring something, you can see that you actually are starting with 0. You're lining the ruler up where 0 starts your measure, and 1 is the first unit over, in this case centimeters. In this Minecraft, we're not actually starting at 0. We're starting, our first coordinate was 220. So we don't actually have a 0. So that means what we need to do to make sure we get the right width is when you subtract the 2, you need to add that 1 back in, because you're not starting at 0, you're starting at 220, so you're not actually counting the first block. So anytime you do this sort of measurement and you don't start at 0, you need to add 1. That means that it is actually 22 blocks, because we received 21. It is actually 22 blocks to the left and right. It's very simple to do the x coordinate, which is down below. You can see that again. We are at 12 on the bottom, and 17 minus 12 is 5, plus 1, of course, is 6. So it is 6 tall. Okay, then our last coordinate that we have is 133 minus 125, which of course gives us 8. But we add 1 to that to get 9. So that means that our block is 22 wide by 6 tall by 9 wide. Now, if we want to leave 1 space here, we do. We have some redstone. If I put a redstone chunk right by here, I get a connection, which is not good. And you can see that we, of course, have redstone running over here in some cases, like right here. So if we drop this down by a copy of itself, we end up with connections like that. So we want to leave a space. So we add 1 more to our width, which makes it 10. Now all we have to do to copy is I can stand back here and we pull up the clone command, and we'll get our targeted block here just so we can see that once again we are starting our source at 220, 12, 125. So I pull up the clone. And we're going to sort at 220, 12. I'm just hitting tab because it's there for me, 125. All we need to do is add our ending block, which we already have its coordinates, which are 241, 17, 133. And now we just have to add these numbers to where we started. We don't want this to move left or right. We want it in the same place. So we go ahead and go with 220. Same thing here. We don't want to move it up or down. So we go with the same 12. And then, of course, the last chunk of this is where we do want it to move. We want it to move 10 forward. So we're just going to make this 135 and hit enter. And as you can see, we now have a copy of it sitting right there. That is exactly 1 away. So there's 2 of those. All we have to do now is pop the same clone command up and keep adding 10 to this number. That'll do it. So this is the 3rd copy. So it's here 1, 2, 3, 4, and 5. And you can see it's taking the server a while to pop these up. 1, 2, 3, 4, 5. What do I have? 4. I have 4. So we need 4 more. We just keep doing this. So there's 1, 2, 3, and 4. Now we should have 8 of these. We'll get rid of this. You can see this. We have 1, 2, 3, 4, 5, 6, 7, and 8. And they're all here. Other thing that I want to do is connect these up to the bus. So the first thing I'm going to do, I'm going to get rid of these blue blocks. I don't necessarily want them there. Those were just for us to copy. And of course, I could have got rid of them first when we did our copy operation, and they wouldn't be there at all. But I will get rid of those, and I can do that either by recopying, or I can do that by doing it manually. Of course, I like the copying piece. So I can pop my commands all the way back to where I started. and redo them. Now you can see we've got rid of the blue. Now it's time to do this. We still need this enabled line going all the way down, and I could have copied it, and that would have been one way to do it, but I decided as a separate exercise, we're going to leave it to do another way. So you can see that we start here once again. I'm going to fill forward this totally with air. So we can use the fill command for that. It works like this. Where do I want to start? I want to start at my targeted block, so I'm just going to tab over. It says, where do I want to end? I don't want to change this, once again, the up and down, but I do want to change this. And we just did how many? We did 8 of those, and they're 10 wide. That gives us 80, which works just fine. So we add 80 to this number, and we get 216. And then what do we want to place it with? We want to place it with Minecraft Air. You can see we've done that, just like that. Now we want to do the same thing with this next block. You can see that is going to actually change what? We're just going to go down 1. So in this case, we just want to change this number. Actually, we want to subtract 1 from it because we're going down, not up. In this next one, we're going to leave for the time being. Okay, that's going to be block number 12. That will be redstone. And we can do it very quickly as well. In case of this, now we change this to redstone wire. There's our wire. Except I got it 1 too low. Actually, it should have been at 13. So, and now that I have made that mistake, I need to change that to our yellow blocks, which are yellow concrete. Right there. Go back and run our previous command for wire, but it needs to be on 13, not 12. That we've done that, we have set all of this. Now it's just a matter of connecting. Just like I've got this connected to the first wire in our bus, 0 bit, this one is going to connect to bit 1, bit 2, and so forth. So now, all I have to do for all of these is simply do this. You can see that we have the control connection coming in here. So that's a very simple matter. I'm going to replace the blue here with yellow. And for all of these, we're just going to do this. That enables all of our connections, and then we just bring this one over. So in this case, this goes to the next bit. And you can see that one comes off the inverter right here. So we simply do this. And then we're going to have to bridge, in this case, to here. Okay, there's the connection to 2. And we wire that. Now all I have to do is keep doing that. This one's going to connect to bit 3. So let me get that done high speed, and then we will resume. Okay, now you can see they are all connected up. There's bit 0, bit 1, bit 2, 3, 4, 5, 6, and 7. They've all been connected to the bus properly. Now, of course, the next thing we have to do is make sure that our signals carry all the way down. That means repeaters. We have to do the enable line as well as these, which might mean we have to move things around. So we're going to turn all of these on. Like so. And then we need to get our repeaters in place where we need them. We need to make sure that the signal arrives at this repeater. So that has to be at least a 1 to hit there. And of course you can see down here, I need that signal to go all the way to these 2 blocks. And so our first repeater that you see is right there. That means this signal needs to be a 1 here. So we just need to get our repeaters in place, and we'll do that high speed as well. Can't forget the bridges either. These all have to be powered as well. Alright, we're going to turn off the enable and all of these. And just check our circuits, because since they have SR flip-flops, you can kind of expect some, I should say SR latches, you can expect some unusual results. So these shouldn't be powered necessarily, except just this inverted line. So all I'm going to do is turn off all of the different signals and flip through here to make sure that everything is good. You can see nothing is powered here to the left, nothing is coming out of the circuit to make sure it's powered. So we want to make sure we have that. And then I'm going to flip all of these and check without the enable one. Make sure that all of ours, we have to get all the bridges as well to make sure that they are powered up and powering on our circuit. So you see all of these should be wired in here to that point. They should make it to this inverter, because that inverter will then boost the signal going forward. It should go here, and none of these should be on this inverter side. If they are, then we have something, our circuit's in the wrong state. As you can see right here, we have to boost back here. Now, actually need to put a repeater there. And now the inverter side goes off, and we have reached our signal. We'll probably have the same thing right here. There we go. We have got all of ours, and the enable should be on, so now it's time to test. We're going to start testing by just turning everything off. And then we're going to enable quickly, like so. What that should do is make sure they're all off, and you can see the lights indicate they are now all off. So our stored bit is 0. And of course, to change that state, let's put the last bit and the first bit on. That's bit 6 and 7. As you can see, we don't have anything changed actually in the register. Those are still storing the 0. But when I hit this flip and flip this quickly, you can see that now I have those turned on. That's exactly what I have here. So I've moved the value from the bus into the register by enabling. Of course, now I can set whatever value I want on this bus. Let's go with every other in this way. All the even bits are turned on. Or odd, if you want to look at it, depending on which base that you want to use. Now you see I've got a value here on the bus. You can see it's every other bit starting with bit 0. So bit 0 and 2 and 4 and 6 are on. And then over here, we still have the value we've stored. As soon as I enable this with the flip, you can see that our value now has moved from the bus into the register. And now I can turn these off and get an independent value. And there you go. So you can see that we now have an 8-bit register. Each one of these D-type flip-flops is storing the value of 1 bit, and we've connected each of those to one of the lines on the bus. So they're storing it. So we can store now what 8-bit value we would like over here. And so this structure here that you see actually becomes our Minecraft register type 1. We will actually be simplifying this shortly, but this is what we have for now. This is our register on an 8-bit bus. Set a value on the bus, flip the enable, and the register will pick up the value and store it. So there you have it. I do hope that this is interesting. It is a actual, as we've worked our way through all of these sessions, 33 to build something as a useful circuit. And here we have what I would consider our truly useful circuit is an 8-bit register. Anytime we want to store 8 bits in value, this is what we need to build. And all we have to do is copy this where we want it. So that is it for Minecraft Math and Computers, episode I33. I hope you enjoyed. If you did, give me some thumbs up down there. Subscribe to make sure you get more. And that is it. I hope you have learned, and I hope you keep on learning. This is Imroy, out.